along an isoquant, what is dq? As you move along an isoquant, a given isoquant, dq is 0. Because by definition, if you move along a given isoquant, output is staying the same. If we move from point A to some point nearby, A prime, but we're on the same isoquant, then dq is 0. In fact, as you move along an isoquant, dq is 0. So moving along an isoquant, we have dq equals 0. Just by definition of an isoquant. But what is dq? dq is this. Now, setting this equal to 0, we can solve for dkdl. And dkdl would just be the slope of the isoquant at a point. Okay. Let's take this equation right here and solve for dkdl. Notice we could write partial f partial k dk. Bringing this over to the right is minus partial f partial l dl. Dividing both sides by the differential dl, we would get partial f partial k dkdl equals minus partial f partial l. And then dividing by both sides by the partial derivative of f with respect to k, we finally get dkdl equals minus 1 times partial f partial l over partial f partial k. Now this term right here, that is just the point slope of the isoquant. See, dkdl? Instead of a dy dx, it's dkdl, because k is measured on the vertical axis and l on the horizontal axis. So what this is saying is the slope of the isoquant is just minus 1 times partial f partial l over partial f partial k. And in 301, you just called this partial f partial l the marginal product of labor. Partial f partial k is just the marginal product of capital. So that's where this formula, the slope of the isoquant, is it just equal to minus 1 times the marginal product of labor over the marginal product of capital. Now, in 301, they don't assume that you know calculus, so they just tell you that the slope of the isoquant is just minus 1 times the marginal product of labor over the marginal. Yes, John. Yes. Another name for the slope of the isoquant, actually, the rate of technical substitution actually is minus 1 times the slope. Notice the slope is negative. So if you just want it to be a positive number, you just multiply it times minus 1. So in 301, the rate of technical substitution, which is just the absolute value of the slope of the isoquant, is just equal to the marginal product of labor over the marginal product of capital. Okay. Now, to get this expression that the rate of technical substitution is the marginal product of labor over the marginal product of capital, we use the concept of a total differential and the idea that moving along an isoquant, dq is always 0. So that's how we got that. So that's where that formula that you used in 301 comes from.